All right, so we have got right here a simulation set up. Now, this question is not one like AP would give you because you could set this simulation up in different ways where the answer wouldn't work out the right way. I was just counting on you guys kind of running through, if you have a random digit table, how you would probably set this up is you could have a number of different results. You could have 0 as a result, 1, 20, or 50. Now, because you're not going from 1 to 100%, on a random digit table, you can only go to 99. So you have to go from 0 to 99 instead of 1 to 100. So if the first 80% is going to be modeled, I would go from 0 to 79. Now for the next 15%, I'd have to go from 80 to 94. And for the next 3%, I'd have to go from 95 to 97. And then the last 2% would be 98 to 99. So I can't actually go up to 100. If it helps you to write it out as 1 to 100 first and then just subtract 1 from each value, that might be a good thing to do. So now we just need to figure out, as we go along, we are trying, in this situation, we're simulating how much a person might win when they buy 10 lottery tickets. Okay, so in this case, this would be one trial. This is not the actual answer like we saw yesterday. So in my first trial, I start with these digits. My first two are 36. Well, that's $0. 51, well, that's also $0. That falls in the range of 0. 83, that falls in the range of $1. I've earned $1 so far. 67, that's 0. 97, well, here, that one happens to fall into that 20 bracket right here, so that's going to be $20. And then 89, that's another winner right there, but for $1. 11, 60, 55, 42, these are all losers, we should say, I guess we could say. So now if I add up my numbers, 20 plus 1 plus 1, I get $22. So however many of you got A as your answer, that is correct. And there we go. Like I said, AP would not set it up this way. And the reason they wouldn't is because you could have just as easily decided, oh, you know what? I'm going to have 0 to 1 represent the 50, and then 2 to 4 represent 20, and then so on. If you did that, that would throw off your answer. But I figured you guys would set it up the way that I did, so I thought it was worth it. But there we go with that. There it is. Okay, so here's our agenda for today. It doesn't look like much, but you know, we got quite a bit going on with this stuff right here. And so let's go ahead and get started. Sorry for that delay. So of course, kind of some general information to get started. Samples are drawn from populations. If you have everyone in the population surveyed, it's called a census. Of course, we're going through the national census every 10 years this year. Of course, a sample survey is kind of just another way you could talk about this. But you could say I'm taking a sample, I'm doing a sample survey. It's kind of redundant. The survey sometimes refers to the actual questions that are answered. The sample statistics and population parameters are those summaries of the data that you either get from the sample or from the population. And we're familiar with this to some degree. We've already worked with X-bar and mu, S and sigma. R and rho, B and beta, those are ones that we haven't seen, and generally speaking, we don't even see those in this course. And then the parameters for proportions that, yeah, we will see that later. We will see this other stuff later, I should say, but it's not for a long time, and we'll get to that when we get there. Okay. So when you're doing a census, it's very time consuming. I mean, notice that it's a year-long process to get a census done. And anyways, censuses have issues with accuracy. I just found out the other day that only 44% of people in Coconino County have filled out the census. So that tells you, you think the census is measuring everybody, but it's only a lot of people just don't respond to it. So it could miss important parts of the population, and And because it takes time, opinions and responses, like if it's for an opinion poll, that could take some, that could change over the course of trying to collect all the data. So it's not necessarily the most accurate. So samples frequently are actually more useful than censuses are. Okay, so let's consider a scenario, and we're going to refer back to this a lot today, kind of add different nuance to it each time we talk about it. But let's say you're interested, and I'm interested, and maybe you are too, on like, what are the actual opinions out there on whether we should come back to school after the first quarter? Maybe that's something you have a lot of interest in figuring out the answer to. So just knowing what you know now, I want you to kind of think about how you would go about collecting that information. And we haven't talked about the stuff yet. You might have already read chapter 12, so you have some ideas. But anyways, I'm going to put you into some breakout groups. And when you're in there, just kind of discuss this question a little bit. And I'll get a few people to respond with what they came up with. Okay, so we discussed kind of different ideas at the beginning. Now let's kind of go into some bad ideas. And if these came up, that's fine. I don't want you guys to feel bad if this is kind of stuff you threw out, but one bad idea is what's called convenience sampling. And it's the laziest form of sampling where you only talk to those people or survey those objects that are closest to you. And that can be closest physically, closest relationally, or both. And so for a survey to be valid, it must be drawn from a random sample, and a convenience sample violates that principle. So you really can't trust anything that comes from a convenience sample. So it's just a big no-no. Make sure you can identify it, say, oh, that's convenience sampling, and so these results are invalid. So just in general, talking about our question of interest for class today, coming back to school after first quarter, what would a convenience survey look like?
Asking your friends.
Perfect. Yeah, you can ask your friends. That's easy, but wouldn't be very representative of the entire population. Okay, so convenience sampling, pretty straightforward idea. Voluntary response. It's similar in some ways, but they're not necessarily like the most convenient. So voluntary response is that if the only participants in the survey are the ones in the sample are the ones who volunteer to be part of it, it could be biased towards those who are passionate about the subject matter. So you also need to make sure a truly representative survey includes people who are not excited to participate because they might have different opinions about this. And so again, coming back, what would a voluntary response survey look like for a question of interest?
Just a bunch of teachers.
Well, it might be teachers.
Maybe like those people who stand outside of grocery stores and ask you if you want to answer a survey.
Exactly, yeah. I mean, that would be an idea that was thrown out. It's in the same vein as what you're just talking about. Was if there was a survey posted on the Flag High page, it's like, hey, please fill this out if you have time. Well, that's a voluntary response kind of sampling. And yeah, if you're walking to the grocery store and someone tries to poll you on some question, yeah, I mean, it's only the people who care enough to answer those questions that are going to be polled. So there you go. Good ideas there. Okay, so those are some bad survey designs or sampling designs. So here's some principles of good survey design. I should say sample design, but anyways, must be randomly selected. The sample must be representative. The sample must minimize bias. And we're going to talk about bias toward the end of class. And it's going to basically give you a skewed statistic at the end that doesn't match the true population parameter. Now, the sample must be large enough. And one thing talked about in the book is that the exact number doesn't matter. It's not like you're shooting for exactly some percent of the population. If you have a small population, 10% is a good number to shoot for. But if you try to get 10% to the US, that's over 30 million people. So that's not reasonable. So it doesn't, you're not looking for a certain percent, just a large enough sample. And we'll see later why having 3,000 people in a sample for the entire United States is plenty enough to get an idea. Okay, and we'll talk about, well, I should say, talk how bigger, not bigger populations, but bigger sample sizes affect samples later. Okay, so when I ask this question, what I want you to think about, we're asking this question on coming back to school and getting opinions on it. So how would we make sure that our sample is big enough? And how would we make sure that our sample is representative?
Would it be like our parents?
Well, that actually is a good point you bring up, because one thing I intentionally did when I phrased the question was I said, getting people's opinion. So are we just talking about students, or are we talking about parents? Are we talking about teachers? Are we talking about everyone in the community, even people who aren't associated with the school district? I don't know why they'd care a whole lot about going back or not. So that's a good point you bring up. Maybe the parents need to be included. And as the researcher coming up with this, you get to decide what your population of interest is. So you can decide right now, oh, my only population of interest is Flag High students, which makes it a little easier. So you just need to make sure you're being representative of that. And hopefully you can kind of see the point we're going toward. If you decide your population of interest is everyone who's associated with FUSD in some way, parent, student, teacher, administrator, then that makes it a much bigger population that needs to be represented. Okay, what about sample size? This isn't a trick question, by the way. What would be a good number of responses you'd be hoping to get at a minimum?
100.
Yeah, and again, that 100 is just like, I don't want to say a random number, it's a nice even number, but you know, if you could get 100, if you could get a few hundred, you know, you could decide what makes the most sense to be representative. Okay, so there you go. No, I'm not trying to be like throwing a trick question in there for that. Okay, a few other things about sampling methods. So there's another term that's thrown out called the sample or sampling frame. And this is not exactly the same as a population. It's very, very similar. So your population, you might decide, was like for this last one, is people who live in Flagstaff. If that was the population of interest for this problem or a different problem, the sampling frame is going to be an actual list of every Flagstaff resident. And it's those that we have information on. So we're going to have, hypothetically or realistically, a list of people who could be part of this survey. And those people make up the sampling frame. Okay. Now, you could draw a lot of samples from a population. So if I had all, however many of you are in this class, about 20, if I had all 20 of you get a sample of Flag High students, none of you would have the exact same sample. And when you get that, it's called sample variation. It's a natural thing, as you are well aware. Now, it's also called sampling error, and we're going to come back to that at the very end. So anyways, I just wanted to throw that out right now, but we're going to come back to the idea of sampling error right at the very end of class. So here are some sampling methods. The simple random sample, SRS, is the most basic, but it's also probably the most frequently used. I don't know if that's true, but I feel like it's the most frequently used. And the essential idea is that if you have your sampling frame, you could number everyone in the sampling frame, get a random number generator to pick X number of people, whatever your sample size is. I want to draw 100 people from the population of Flagstaff. They're all numbered. I get 100. There it is. That's my sample. Okay, so kind of a straightforward idea. Here's the thing, and this is only true of simple random samples. Every sample has an equal probability of being selected. So if everyone in the population or is in the sampling frame more or less, and it's just random people, then there's no particular group of people that's more likely than another to be selected. No particular sample that has a higher probability. And that's not true of our other ones. I will hopefully explain that idea. So a simple random sample. We're trying to figure out opinions on coming back to school. How would you do a simple random sample for that?
Maybe ask people like in their advisement class.
Okay, yeah, and that's part of maybe the methodology of it. But just more to this idea of simple random sample, what could be our process?
Using a random number generator.
Random number generator, and the only other thing we'd need, and we'll just limit it to make it simple for now. We'll limit it to Flag High students. So what else would we need in addition to a random number generator?
Would we have to number the Flag High students?
There you go. Now you guys do have ID numbers, so maybe that could be used in some way. But yeah, you'd need the list of students in the population, which is your sampling frame. And you would need to randomly generate your sample from there. So one thing to keep in mind with this is that you are picking your sample ahead of time before you ever talk to a person. So you know you have a big list of sampling frame, you create a smaller list of your sample, and here's all the people I'm going to contact in some way. There's your sample, and you're going to go at that point and actually talk to people for the first time. All right, so that's basically the idea. Stratified sample. So let's say there are different classes or tiers or divisions or whatever it is within your population. You want to make sure that each class is represented proportionally. You can use a stratified random sample to accomplish this. So those classes or divisions are called strata, which is why we call it stratified. So here's some examples. These are all strata related to humans, okay? So, and I'll come back to that in a second, but gender, socioeconomic, I put strata, I meant status, race, age, skill level, so on. So there's all kinds of strata you could split this up on, but keep in mind, when you're doing sampling, you're not always sampling and surveying people. It could be like trees in a forest. So you might split it up like, I want to stratify based on age of the tree. So keep in mind there's strata for different types of survey subjects. Random samples are taken within each strata to generate the sample. So that would still be random number generation, but you would want to make sure that the samples are proportional to the population distribution. And here we're going to look at an example of that. So let's say that we're splitting up a population into socioeconomic classes, lower class, middle class, and upper class. In this hypothetical population, it breaks down this way. 50% of the population is lower class, 35% is middle, 15% is upper class. So when you're doing your sample, if you wanted a sample size of 300, you'd need 150 randomly drawn from the lower class, which is 50%. 105 randomly drawn from the middle class, there's your 35%, and 45 from the upper class, randomly drawn. So there it is, stratified. We'll come back to stratified in a second because I'm going to introduce cluster sampling, which seems very similar at first, but hopefully you can tell the difference between it. So in a cluster sample, the population is first divided not into different classes, but into different clusters. And each cluster is supposed to represent the population as a whole. Okay, so it's not really explained very well on this slide. I should have maybe said something, but each cluster is supposed to be representative of the entire population. So you have to be careful to make sure that your clusters are this way. So here's by way of analogy. There's something like this in the textbook. I just modified it a bit. If you were going to do a stratified sample of lasagna, you would first need to randomly sample the pasta layer. Get the pasta, randomly pick out little bits of it. The sauce, you need to randomly select the sauce from throughout the entire pan. And then the cheese, randomly select, sample that. So you're dividing it first into the types of layers and then sampling within. For a cluster sample, ideally, just a single piece of lasagna cut from somewhere on the pan should be representative of the entire pan. I think it's fair to say that's true. So if you use just a single piece of it to represent the entire pan, or two pieces of it to represent the entire pan, that is a cluster sample. So here you go. Anytime you grab some kind of casserole, you can announce you're conducting a cluster sample. Maybe that's a helpful mnemonic for you, or not mnemonic, but just metaphor. All right, so here, this is actually from the Unit 4 reference posters that are on the Canvas Classroom, but this is just a good visual to kind of show it. We got animals, and in this case, we've got 4 clusters that are all representative of the population overall. So if we picked a couple of these clusters randomly, then we could get our sample. And let's imagine there's actually dozens, hundreds, or thousands of these clusters, and we just pick a few of the clusters. Now, stratified, and up in the corner it says same within, different between. So the strata are different between them, but they're the same within. And so what we're doing is we are selecting from within the strata to generate our sample. So hopefully this visual is helpful. So just kind of think in a cluster, each cluster should be representative of the entire population. And no, stratified, that's definitely not true. Okay, the systematic sample, this is one of the easier ones to understand. Actually, when there's multiple choice questions and matching up and stuff related to this, this tends to be a little easier. So when we say it's systematic, what we've got, let's look at a scenario here. Your quality control in a factory for some product, and you decide that every 50th item you're going to pull off the conveyor belt. Well, you start with one, just a random one maybe, and then from there you count every 50th one and you take it off. Count to 50, take that one off. Count to 50, take that one off, and you get the idea. You do this until you've gone through the entire batch, and now you have your sample that you can select from. And in something like this, it might actually be good to do a systematic sample, because otherwise we might be a little biased to only picking the ones that look best or only picking the ones that look worst. So if we just limit it to the 50th, that controls our instincts a little bit. So let's say you're going to do a systematic sample, but you're not sure exactly how many you should count until you get the next subject. Well, you can divide however many are in your sampling frame by whatever sample size you're shooting for. So if you're got 12,000 and you want a sample size of 300, you just divide. Of course, I set it up where it's a nice even 40. If you don't get a nice number like that, which is usually the case, round down, and that'll make sure you end up with more than you were looking for, so that you can always make sure you have enough in your sample. Okay, questions on these sampling types? Okay, hopefully it's feeling clear. And just conceptually, I feel like this is something that it's like, okay, this is all pretty straightforward. It gets a little bit hairier when you're looking at specific situations, and it's kind of hard to tell, oh, is that cluster or is that stratified? That's where most people struggle. Is it cluster or stratified? So there's some stuff in your homework tonight where you can kind of parse between those two. Multi-stage. So this is just as simple as combining different types. So you could do a cluster, stratified, and systematic sampling all in the same sample. So let's say that we're trying to get some information and we start with zip codes. So I've got a zip code here that is that area. Then I cluster sample. I'm going to assume that within the zip code, all of the census blocks are the same. And the census block itself is literally like a block on the map. Maybe not always a rectangle, but it's a block. And we can imagine that every one of these blocks is going to be fairly representative of this zip code. All right, so now you've got your census blocks and you just select randomly. Random number generator tells you to pick this one, and this one. Okay, so we did a cluster sample within that stratification. And then finally, within those census blocks, we go to every 10th house, because that's what we calculated was what we needed to do. All right, so that's multi-stage. All right, so another idea just to throw out there is if you did multiple nested stratified samples, that is another thing. So let's say you stratify based on gender. Then within gender, you stratified based on age. And then within that stratification, you stratified based on socioeconomic status. And you can find stuff like this where there's tables and results and stuff like that. So this is not an uncommon thing, but it's pretty complex. All right, so multi-stage, hopefully again, clear enough. Conceptually, hopefully it's clear enough. Setting it up is a little more complex. So this shouldn't say stratified up the top. I just forgot to change the title. So I say in breakout groups to set up a multi-stage sampling design. It doesn't have to be that. It could be any one of them. If you want to combine it and do a multi-stage sampling design, that's fine. But if you just pick one of them, I want you to come up with a sampling design to figure out how you would sample to figure out opinions on coming back for the second quarter. I'm going to put you into your breakout rooms again, and I'll give you about 5 minutes to kind of talk through it, figure out all the little logistics on that. Okay, so any volunteer to say what kind of sample design did you come up with for this question?
We said going by grade and then having like cluster samples inside those grades.
Okay, so what would the first part be when you did divide by grade? What would you call it?
Stratified.
There you go. So you start with stratified. So explain how the cluster would work from within the strata, the different strata.
I don't know. It just like make the sample smaller.
Okay.
Instead of doing like 400 kids per grade, we'd be doing like 50 to 100.
Okay. So we just need to define what our clusters are going to be. So, I mean, but that's not a bad idea. Like we could.
Yeah, because we said divide them up into different grades because, well, I say that because it's like depending on the class, some kids would want to go back more than others. Like seniors want to have their like senior year, freshmen want to have their freshman year. So.
Yeah, so I definitely like that idea, the stratified, and maybe we just leave it at stratified, and within the different levels, we just randomly select seniors, juniors, sophomores, and freshmen. So, but that's a fair design. Thank you for that. Other ideas? Did any other ideas come up? Okay, I don't know if everyone kind of came to that same idea in your discussions, which is kind of a good logical place to go with this. So if that's where you kind of landed, that's a good place to be. So if you did consider all the stakeholders, including parents and teachers. Maybe, of course, you'd include multiple levels of stratification, right? So maybe you start with stratifying between different types, parents, teachers, students, and then within you could stratify even further, secondary and elementary, all that kind of fun stuff. So yeah, did anyone else have anything novel that they talked about, even just as an idea, not necessarily fully formed? Okay, I'll take that as a no. So just one other idea maybe to throw out there, and I don't think this is better than that stratified sample. This is just to search for any other way of sampling this. You know, some classes at FHS are a mix of students. Like when you have a band class, it's going to be all grade levels in a band class. Maybe if you could find enough classes with a mix of grade levels, you could consider that representative of the school. And so maybe you could sample like some elective courses like photography, art, stuff like that, and then of course band, orchestra, to figure out maybe that would work as cluster sampling. You know, just a thought there. I don't think that's better than stratified, but it could be done. Okay, so this is just to set you up. But now let's talk about bias. So we're talking about just how we pick who's in our sample, and that's a really important component of sample design. But now we need to talk about how sampling can go wrong. And assuming you picked a good sample design, bias can still affect it based on, you know, something that went wrong in your sample design that you didn't consider, or your survey design, like the actual questions that you asked. So the first one, this is a flaw in how you even collect your sample, which is undercoverage. And there's a fine distinction between this and the next one, and we'll come back to that. But undercoverage happens when a segment of the population isn't even included in the sample at all, or it's not represented proportionally. So sometimes undercoverage happens intentionally. You're trying to skew the results because you want a specific answer. You can make anything happen with statistics. We haven't talked about that a whole lot, but you've probably seen that in your life. So yeah, you can make anything you want with statistics if you skew it enough, and kind of omitting people from the sample is one way of doing it. But it often happens unintentionally. So here's an example of one that's trying to be a good survey. So a statewide survey is sent out to carefully selected homes, but the sample, from the beginning, the sampling frame didn't include PO boxes. So whatever segment of the population only uses PO boxes, and there's a lot in the state that's the case, that entire segment is underrepresented, and therefore you get under coverage. So they were omitted from the sample frame when they weren't supposed to be. Okay, on its own, that's pretty straightforward, not a whole lot to it. And it can be confused a lot with non-response bias. So maybe you design everything well, but maybe not everyone responds to the survey. And you're never going to get 100% results or feedback, but maybe you get very few responses. And then you get non-response bias. So these were people who were actually included in the sample. It wasn't under coverage, but they just didn't respond. So therefore it's non-response bias. So let's consider that same survey. Let's say that it was, again, very carefully selected homes, but the survey was only in English. So non-English speaking families don't participate at all. They are underrepresented due to non-response bias. So again, you kind of have to factor all these different possibilities in when you're designing your sample. Okay. Now, if you are worried about non-response bias, there's the idea of opting for quality over quantity. Yeah, you could send out 10,000 letters and hope to get 20% of them returned, which is actually a good response rate. Or maybe you could focus on, instead of 10,000, maybe you could focus on a sample size of 500 where you send someone to the house or call them or something like that, and call them until you finally get them on the phone. So actually gathering a small number of responses rather than getting a lot of surveys with a low response rate is probably a better choice. Okay, and so just the distinction here, if a person never responds to a survey, but they're included, that's non-response. If a segment of the population was never even included in the sample to begin with, it's under coverage. It is B, under coverage. Wow, that's some great English I've got there. You feel English? That's impossible. If voluntary response sampling or convenience sampling is used, it pretty much always leads to non-response bias. Remember we talked about that voluntary response and convenience. You're only sampling people who are like right there and just happy to participate on some level. So there you go. A lot of segments are omitted. Okay, so those are kind of flaws in how the sample is collected. But this is a response bias is basically anything that affects how people actually respond to the survey questions. So that is still a possible source of bias. Okay, anytime someone's response is biased due to some factor in the way the questions are presented to them, it's called response bias. Okay, this is an important distinction as well. If someone is being surveyed and they don't respond to a question, that is still response bias, not non-response. So we talked about non-responses whenever they just never participate when they were supposed to be part of the sample. But this is, I'm just not going to answer that question. That's a response bias. And we'll talk about why that might happen. Non-response bias is, okay, I already said that. It's only not participating. Okay, so here are common sources of response bias: poorly worded questions or intentionally biased questions. You could get nonverbal cues from the questioner, such as giving positive feedback when the response is desired and negative feedback when the response isn't the desired one. Or maybe presenting oneself in a way that might bias a person. Let's say you're trying to collect some political opinions and you're wearing a campaign button for one of the candidates. Don't think that's going to, I think that will bias people in some way. So asking personal questions face to face, and these are like deeply personal questions. If you went up and asked a stranger, have you ever used illegal drugs? They are less likely to give you a response to that. You can still ask that question, but keep in mind how you're asking the question will determine how truthful the response is. So if you ask a fellow student, did you cheat on that test? They might say, yeah, I cheated. If I ask that student, did you cheat on the test? They're going to say, no, I didn't cheat on that test at all. So there are different ways of getting that information. It could be an anonymous survey, so there's no danger for them. Asking questions that require extensive background knowledge. So if I asked you a question, but you had no idea the whole context that it was related to, and we'll see some of this, then that's going to throw off the validity of the response. And giving leading information for your question can lead to response bias. Now, sometimes it's necessary and presented in a fair and balanced way. So anyways, so if it's unbiased, the way you present that leading information, it's okay. Okay, and last little bit here, even question order can lead to response bias. So professional pollers will frequently switch up the order they ask questions just to make sure that doesn't come into play. Okay, so anyone who has thoughts on this, go ahead and tell me what you think about this question.
It's definitely biased.
Okay, how so?
They say that people thought that the economy was in terrible shape, and then they just immediately continue to ask the question. So like people are geared to, like more geared to say that the president is not handling the economy well.
Or and yeah, I mean, there's definitely bias there. Maybe the way that you'd be led to answer this is, well, if the last president left it in terrible shape, but we've seen growth over the last 4 years, maybe the current president's doing a good job. And I did intentionally leave this without names on it. So this could have been asked at any point in US history. So let's keep that in mind. All right, yeah, I agree that's biased. What about this one?
No.
No, just no. Are you answering the question? You're not likely to, or no? I know what you're saying.
No.
So yeah, hopefully everyone looks at that and you're like, I don't think that's biased. There's really no bias there. What about here?
No bias.
All right. Does anyone else think there is bias?
There could be. The questioner could have asked it in his opinion of effectiveness. Ordered the names and effectiveness.
And that's a good point. That is a good point. What else? Now, keep in mind, it's not biased because you're trying to, you have an agenda behind the question, but what other response bias might come? How do I say this? How else might response bias happen as a result of this question?
For me personally, I haven't heard of any of the other people. So I don't know if that would like promote some kind of bad response.
Exactly. Yeah. You have to have a lot of background knowledge to be able to rate these people. Some of you might have heard of all these people and even have opinions on them. But I'm guessing that you guys don't have strong opinions about all of these leaders. Maybe Macron, maybe any of them. So this is one that, this is maybe a great question for people in a political science program at college who are seniors. But if you're asking the general public, lots of background knowledge required, not a very good question. Okay, and last one.
I'd say it's biased just because it's saying that it's like assuming that the Civil War was already worse than the American Revolution.
Okay. Yeah, that's one source of bias there, absolutely. I agree. Anything else going on that would lead to response bias here? So, well, if I just ask this way, do you guys know how you'd answer this question in the first place?
Yeah, true.
No.
There's no scale.
Right. This is an example. Not only is it kind of biased, like you were saying, Sam, but it's just poorly worded. Yeah, they don't give us any kind of way of answering it clearly. So yeah, poorly worded question here, showing some other bias as well. Okay. So what I want you to do now is, and this won't take you very long, probably just a minute will be sufficient. So take a minute and come up with the wording for a question that gives accurate feedback on people's opinion on coming back to school. So I will put you back in your breakout groups and just spend about a minute. Probably won't take you too long to come up with what you think is good wording. Everyone is back. I want to hear a couple of different question wordings. So any volunteers?
My group said, if school were to start back up in the fall, how likely are you to come back to physical classes? And then like very likely, not very likely, unlikely, like that scale.
Okay, that's good. And I think that's fair. I think it's not biased. Any other wording that you guys came up with?
My group basically said what Zach said. Give them like a scale of how much they want to come back.
That's good. And that goes
Or-
back to,
or we were also gonna say like how, like we'd ask like a couple other questions, get a better idea, like how safe would you feel coming back? That'd be another question.
very good. Very good. I like that. So yeah, getting not just a single question survey. There's another thing. I'm glad you said that, because there's kind of this sweet spot. I don't know exactly what it is, but there's a sweet spot where if a survey gets too long, then you can create non-response bias where people are like, I don't want to fill out this survey. But if it's a few questions, people don't generally mind. So I'm glad you said that. And yeah, that goes back to what Kareem, your group, and what you mentioned earlier at the beginning, where you said you do the 1 to 5. So yeah, creating an actual logical way for people to respond is important. I like the wording. This is, in the big world of creating survey questions, this isn't the most complicated one to come up with, but it is surprisingly easy to create a bad question. So just make sure you're thinking through it. Okay. So one last thing about bias. This is the very last thing before I give you your homework. We talked about sample variation, and the other idea we had for that is sampling error. Okay, it is not a form of bias. So when you hear sampling error, it's maybe a bad name for it. It is not bias, and it's a natural part of any sample design and cannot be avoided. There's a good chance you'll come across a multiple choice question as either you're preparing or on the actual AP test that mentions something about, oh, this has sampling error, therefore it's invalid. It's like, no, you can't avoid it. All right. But here's the basic idea. Since anytime you take a sample from a population, you're trying to get it as representative as you can, but the actual population parameter is likely to be a little different from your sampling statistic. So that difference is mathematically what we'd refer to as the sampling error. And as long as you are reducing whatever that sampling error is, you're doing everything you can. But you can't get rid of it and perfectly guess the population parameter from a sample. Okay, so just wanted to make sure that was mentioned. And we're actually this is gonna be an important idea when we get later. Just before this semester ends, we'll probably cover a little bit more on this. All right, so your homework for tonight, read chapter 13, here's these problems, and I added this right here. You probably do this anyway, but especially for these problems, I really want you guys to try and answer all these on your own. There's only one you have to turn in, so the rest of them just answer in your head. And then, anyways, once you've answered it yourself, then go and check the answer. So even if you're stumped on something, just try and come up with an answer for it. All right, so if you are good with everything we've done, you get to leave about 25 minutes early today and have a wonderful day. If you want to stick around, I'm going to go through a few homework problems fairly briefly.
Thanks, Mr. Davis. Have a good rest of your day.
All right, thanks. Later.
See you, Davis.
Thank you, Mr. Davis. Thank you, Mr.
Bye,
Davis.
Mr. Davis.
Bye. Okay, let's go ahead and start looking at these. I'm not going to write stuff down for this. We're just going to kind of talk about these scenarios briefly. So what's happening here is we've got some sampling strategies proposed to help a PTA determine whether parents favor requiring elementary students to pass a test in order to be promoted to the next grade. So we're just going to assess these sampling strategies and figure out what's going on and what biases might result, if any. So the first one, run a poll on a local TV news and ask people to dial in. Well, if you look at that, and hopefully you're answering this simultaneously at home, but just to answer this, I would say this is voluntary response sampling, and you are very likely to get undercoverage bias and non-response. kind of both of them. People who don't watch the TV news aren't being included, and people who just aren't very passionate aren't going to participate. Hold PTA meetings at each of the 20 elementary schools. Again, this is going to be voluntary response because only the people who are passionate are showing up to PTA meetings. So you're missing out on a large population. Randomly select one class at each elementary school and contact each of those parents. So this would be an example of cluster sampling, and you assume that the parents of one classroom wouldn't be significantly different from any other classroom's parents. So the key thing is just make sure how you contact those parents. You're getting the full sample or close to it. Otherwise, you could be getting some non-response bias. Okay, and what I mean by that, just to clarify, is if you have like X number of parents that in your sample, but only 50% of them participate, then you get non-response. Okay, and then this last one, going through the districts of enrollment, selecting every 40th parent, and PTA volunteers will go to those homes and interview. So systematic sample, that was pretty easy to identify. And this is unlikely to result in bias because they're actually going to the homes. Systematic could potentially be a problem, but it's unlikely to, because you probably get a good representative sample from that. Okay, playground. Some people have been complaining that the children's playground at a municipal park is too small and in need of repairs. Managers of the park decided to survey city residents to see if they believe the playground should be rebuilt. They hand out a questionnaire to parents who bring children to the park. And what are the possible biases here? Well, the biggest bias, and hopefully you're going there as well. Hopefully the biggest thing that stands out is these are parents who are bringing their children to the park. If some people don't like this park, they're not included in the survey. So they might get a skewed response of people really liking the park more than the general population does. Another thing that could happen is if it's questionnaires, how many of them are actually going to fill it out? You could get non-response, but the bigger one is, of course, under coverage. Okay, so right here we've got an online poll at a website, asked a question. A nationwide ban of the diet supplement ephedra went into effect recently. The herbal stimulant has been linked to 155 deaths and many more heart attacks and strokes. Ephedra manufacturer NB Pharmaceuticals claimed that the FDA lacked proof that ephedra is dangerous if used as directed. Was denied a temporary restraining order on the ban yesterday by a federal judge. Do you think that ephedra should continue to be banned nationwide? And there's results. We are going to comment on each of these statements. So that's what the task is. So here's the statement. With a sample size that large, we can be pretty certain we know the true proportion of Americans who think ephedra should be banned. That is a lot of respondents, but this is a classic voluntary response survey. So it doesn't matter how many people respond, it's really not a valid survey to answer the question for the population. Okay, the wording of the question is very clearly biased. Well, there's information, certainly there's leading information in the question, but I think it's fair to say that this is not, it's not biased information being given. It's giving background so that someone can give an informed opinion. So I would say there is information, but it's not certainly not very biased. And if it's biased at all, it's not by much. Okay, the sampling frame is all internet users. So remember, sampling frame is all the people who could respond to this survey. And they're saying anyone on the internet could respond to this. And in one sense, that's true, but really the sampling frame is everyone who goes to this particular website, not all internet users. A very small fraction of internet users are going to go to this website. So the sampling frame is really people who go to this website, if that makes sense. And the last one right here, results of this voluntary response survey can't be reliably generalized to any population of interest. That's true. Really nothing more to say about that. Yes, that's true. Okay. And the last one here. A manufacturing company employs 14 project managers, 48 foremen, and 377 laborers. In an effort to keep informed about any possible sources of employee discontent, management wants to conduct job satisfaction interviews with a sample of employees every month. Do you see any potential danger in the company's plan? Explain. I Yes, yes, I can see some potential dangers here. The biggest one, well, I'll come to the biggest one in a second. One thing is if they're not careful how they select, they could get a very skewed sample where it's all laborers and maybe very few or no foremen or project managers. So these laborers way outnumber the rest of the employees. So you have to be careful there. The bigger potential danger is notice how they're doing it. Management is going to conduct job satisfaction interviews. So it's going to be face-to-face. Now that is going to lead to response bias. How many employees are going to complain to management during one of these job satisfaction interviews? So there's a better way of doing it. And certainly the way they're doing it is not the best. Okay. Propose a sampling strategy that uses a simple random sample. Well, that's always an easy one to answer. You number each employee, get a random number generator, and create your sample out of that random number generator. Okay. Why do you think a simple random sample might not provide the representative opinion the company seeks? Well, we already touched on this, but if a random number generator is used, you might get all laborers. So in the next one, it says propose a better sampling strategy. We really want to get project managers and foremen their opinion when we do the survey, not just laborers. So maybe we do a stratified sample. We stratify based on the job types, and then we select proportionally from that. Okay, and then not only that, we don't do in-person interviews with management. Maybe it's an anonymous survey that's sent out to specific employees. Okay, so listed below are the last names of the project managers. Use random numbers to select 2 people to be interviewed. Explain your method carefully. Now this is one, you could do this with your calculator. If you numbered all these 1 through 14, and with your calculator, you just picked 1 through 14, I think that's a fair way of selecting. Let's say you're using a random number table. Well, in that case, we have a pretty simple way of doing it. Okay, I'm just doing this randomly. So let's say that we only select someone if the 2 numbers are one of our 14. So maybe 05, oh, we're gonna pick Williams, if that's my number 5. 73, there is no 73. 12, okay, so 12, that's gonna be Grigorov. And then there's our 2, but then if we kept going, oh, there's no 58. So we just skip every number that's not in our survey, and we go until we find 2 people who are with the random numbers. So that's maybe how we could approach this. Okay, and just explain all that. So I verbally went through all of this, but if you have any questions, you can stick around. Hopefully you're feeling good about it all. And if you're good to go, then have a wonderful day.